All right. Up next, we have Aaron Luke, Director of Product Management at NVIDIA, presenting Introduction to OpenUSD for Physical AI. He'll dive into how NVIDIA and our partners are advancing OpenUSD as the data ecosystem for industrial digital twins and the next era of AI, including physical AI for robotics, industrial digitalization, and autonomous vehicles. Please join me in welcoming Aaron Luke.
Good morning, everyone. Thanks for joining us on OpenUSD Day at SIGGRAPH. All right, so let's get started. OpenUSD for Physical AI. Our agenda today breaks down into 3 sections. First, I'm going to walk through some of the universal first principles of OpenUSD. Then I'm going to lay out some of the key use cases for the workloads that we're targeting it for in industrial digitalization, physical AI, and robotics. And then I'm going to lean into the content journey that's needed to fulfill that vision and how standardization is important for it and what role you can play in that. So let's start with these first principles. So at NVIDIA, we see OpenUSD as this data ecosystem for industrial digitalization and physical AI workloads. Particularly, these are sort of the 4 key workloads that we see. They all kind of build on top of each other, in which you're doing full fidelity product reviews for equipment, right? And that equipment or products may be manufactured or fulfilled in a physical facility that you are designing and planning virtually in a digital twin, and keeping that digital twin operational after you break ground and actually construct that facility in real life. You then populate that facility with robots. You simulate them in your virtual world to maximize efficiency and safety in these facilities. And of course, you can then take your robots on the road, right? And have autonomous vehicles that are navigating ever larger and interconnected virtual worlds that represent the real world. So what are the unique features of USD that really allow us to create and populate and simulate these virtual worlds? The secret sauce, right, is this ability to aggregate heterogeneous data. And this is something that is really core to USD first principles and how its data models and behaviors enable that. The first key feature is the composition engine of USD, which allows sparse, non-destructive scene aggregation. It means you could have lots of different data come together, layer them on top of each other. This layer can represent different disciplines, different domains, just like data in the real world. And to represent that data, right, you have a very extensible data model with USD in which it's not specific to 3D at all. Every schema is just a raw group of key value pairs that represent data models that may come from existing standards, right? They may be new ones that as we discover new things about the world that we need to represent, but everything in USD is representable via a schema that, again, can all be composed together into a unified whole. Third is the asset resolver and data abstraction paradigms of USD, in which USD is completely storage and serialization agnostic. This is why we always lead with by introducing USD as this data modeling paradigm and composition paradigm, where it's not really tied to a specific file format the way traditional file formats are tied to serialization and storage. The data models can be represented, again, anything that speaks key value pairs, right? So traditional files, whether they're on disk or in the cloud, or coming from a database, or even procedurally generated, it's all can speak USD. So you can store it anywhere and you can serialize it any way you like. This is also a way in which you can ingest existing file formats into USD. And finally, now we have not just Hydra, but OpenExec in the newest version of USD 25.0, which has really interesting paradigms to generalize your post-composition pipeline. Once you have that data composed into your scene graph, you can then now define computations and other proceduralism post-composition to then feed into your render, as well as other simulation runtimes. So when I talk about the UC ecosystem, I always think about it in these two major families, right? One is the data ecosystem for physical AI, right, in which you see this industrial scene as it's like broken out into its component layer stacks for all the types of data that's flowing through that industrial scene for the robot as well as the equipment. And then, of course, we have the stakeholder ecosystem that's more growing membership in the Alliance for OpenUSD, as well as many vendors and DCCs that are supporting USD natively, either through exporting or importing their scene data into USD to have a nice sort of cohesive ecosystem in which 3D data and non-3D data is traveling all together and on the path to collaborate to populate digital twins. But we need a standardization strategy around that. We need content standards for everything that's going in these industrial digital twins. In particular, our goal at NVIDIA is to empower equipment manufacturers to provide USD equivalents of their physical goods to populate these digital twins. In other words, the owner of a physical object who has all the source data should be able to be the one to provide the virtual equivalent of that for the digital twin. And there are four steps to achieving that. One is common data modeling, in which you map existing data sources from those objects, what those objects are capable of, how do you represent that in data models, and how do you map those into either existing USD schemas or new USD schemas that are mappings of those original data models. If you do need new schemas that don't exist in USD today, you need to go through a phased evolution to fill those feature gaps. And then next, we need to align on asset structuring best practices. This way we can maximize content comprehension both by us as humans and the AIs that are processing the digital twins. And of course, we need open governance to actually formalize these standards that we can agree on across industries. So let's start with conceptual data mapping. This is an exercise that has already been undergone within the USD community in which the Material X file format was mapped into USD shade. All right, so this is a perfect example of how data models can be aligned, right? And now you get the bonus interoperability of Material X along with the composability of USD together, right? So these take the form of conceptual mapping documents like this one. You could think of those as like specifications for data extraction. These are living documents that need to stay up to date as the respective formats change. And these are sort of the guidelines that help developers create data transformers, exporters, and what have you. At NVIDIA, we have an SDK called the OpenUSD Exchange SDK that is designed as a strong sense of higher level functionality on top of the OpenUSD SDK for the purpose of writing these importers, exporters, these data transformers that implement the data mappings that are so key to populating the rich worlds of the virtual worlds that mirror the real world. Now, here's where the nitty-gritty comes in with how you evolve USD in phases, right? You evolve the data models, you evolve the runtime behaviors, but you pay this content compatibility tax as you go. So let's start with the top row, right? We know that there are some data models, right, especially for non-3D type workflows, right, that are not currently natively representable in USD. But you want to start prototyping, right? You know you can do custom schemas in USD. You can do custom attributes to sort of prove out the end-to-end of what data you need to flow through USD, right? And then you also need to prototype runtime behaviors around that if there's no existing runtime behaviors in USD for you to hook into to go with that data model, right? So these first two rows kind of go together, right? As you formalize your schemas and you integrate your runtimes, right? You publish your findings, discuss them with the community, maybe exchange ideas with other parties who are doing something similar, and you align on a standard, right? As you're doing that, it's a very iterative process, right? You're putting out content as you're going because you need to prove things out, right? And so you need to annotate that content with the version of the schema that you're doing, with the version of the runtime that you're running against, all the information that's needed to validate that content against whatever candidate runtime you want against, right? So that you can upgrade everything accordingly, right? So that we can all be on the same path and only support legacy content as long as we have to, right? We all make assurances that we will support that legacy content, but we want to get to a point where we can sunset it and move on and update the standards accordingly. So these are examples of some plug-in prototypes that we developed at NVIDIA, right? You can think of these as data modeling exercise just to sort of kickstart conversations in this area. On the far left is geospatial data. So georeferencing is often a often requested workflow for architectural workflows as well as mapping. Right, and here we've prototyped WGS84 coordinate system and proved it out by posing these railways from Deutsche Bahn on top of an open street tile map, and the geospatial coordinates line up as expected. The second example is where we have implemented OceanSim via NVIDIA Warp, which allows you to take Python-like code and cross-compile it into CUDA and run it on your GPU accordingly. Right? We're able to do that, point to it within USD, and basically embed that simulation inside of USD View, which doesn't have a native simulation engine inside of it. So this is a potential paradigm for that maps to other standards like FMI, functional mockup interface, right, where you can declare your simulation inputs and outputs and ship the binaries for the implementation accordingly. And finally, on the far right, we've prototyped a paradigm for dynamic payloads for external data binding. What you're seeing here is not visually exciting, but what it's doing, like I said, is it's actually populating this USD stage by making queries to the Metropolitan Museum of Art's REST API to populate a USD with the catalog contents of that museum's art. And so this is a way you can, and it's configurable as a dynamic payload, so you can do data LOD to expand to a certain number of departments, a certain number of objects within the department, so on and so forth. This is a toy example that we think is going to seed a lot of development around formalizing data binding paradigms for things like IoT and other operational data in industrial facilities. Next, principles of OpenUSD asset structuring. So this is how we scale our vertically and horizontally for the size and breadth of the scenes that humans and AIs need to understand. And so there are 4 principles here. The first is legibility. A domain expert should be able to correlate the output USD with the source data. A CAD expert should be able to look at the USD and really kind of understand where the things they care about are. Modularity, reuse of atomic content. So one of the key composition arcs within USD is referencing, right? So if you get the same object multiple times in a scene, you should be able to reuse the atomic version of that object over and over again and instance it accordingly. Performance is how you both scale in terms of the speed in which it's being processed, as well as complexity. How can you reason about it if everything's all over the place, right? Note that there is often a trade-off between performance and legibility, right? Often things are performant if you pack them all into single objects and what have you, but then you might lose a little bit of legibility for folks who are expecting like a hierarchy of objects that they would observe in other tools. And finally, navigability. You should be able to easily find what you're looking for, both spatially and within the hierarchy of the scene. And we published some white paper on this that's linked here in the QR code. An example, key example of good best practices for structuring is the model hierarchy in USD. You can think of it as a table of contents for your entire scene, right? So here this is a very simplified factory, right? So already you can see it's, but it already feels a little bit cluttered, right? So what do you really care about? You just care that there's a factory that has a level, that has a north wall, and 2 welding robots in it, right? So you can identify significant subsections, or in USD terminology, models in your large data sets, right? Here, the individual models are called components, like these robots, right? You can aggregate them together into meaningful groups called assemblies, right? So for example, you can have multiple robots along with the equipment that they're working on as a work cell assembly, right? And then assemblies can be nested, in which you have multiple work cells that make up a factory. Note, I specifically use these terminologies to offend the CAD folks in the room because USD components and assemblies don't map exactly to what CAD components and assemblies are. We're going to run into a lot of terminology collisions, certainly today, but over the course of digital twin developments, and that's why it's all good to get in person sometime and teach each other where these terms collide and maybe invent new terms. We'll see. And we have literature on this as well. Okay, and then finally, open governance. As I mentioned, the Alliance for OpenUSD, which turned 2 years old this year, it was formed in SIGGRAPH 2 years ago by founding members Pixar, Adobe, Apple, Autodesk, and NVIDIA. And we have a growing list of general members. Our newest ones that we'd like to welcome today are Esri, Renault, PTC, Techsoft 3D, Accenture, Intrinsic, HCL Tech, and Coca-Cola. So you could see an ever-broadening, eclectic mix of industries who are all really, really excited about industrial digitalization and other benefits that you get from heterogeneous data aggregation. So what do we think of when you talk about USD as a standard, right? It's very vast, but the vision is to curate it as a coherent multi-part specification. So let's start at the inner loop here of this onion ring. I'm currently serving as chair of the core specification working group in the AOUSD, and our mission is to normatively specify those inner workings of USD, the composition engine, and the value resolution semantics, and the data models that feed those. Right. Beyond that, we have the geometry working group and the materials working group, right, who are making normative specifications around meshes, around material nodes, things like that. You could think of these inner rings as what does an implementer need to implement USD compliant readers, right? And then as you go further out, now that we have OpenExec, right, we can normally specify the computation rules around USD. But even without OpenExec, there are things like hierarchical visibility that need to be normatively specified. Again, this is all about reading, right? And then when you get the outer rings are these content specifications. I'm going to go into later about the concept of SIM-ready, right? But this is like, you're a DCC maintainer, you're an ISV, you're an equipment manufacturer. What are the specifications you need to write USD compliant geometry and materials that are then read by these inner rings, right? And we're going to get to why that's so important in a little bit later. But first, let's talk about some of the use cases that's driving all of this technological collaboration, innovation, and standardization. So at NVIDIA, we've built a modular set of libraries for physical AI simulation for developers to build out their physical AI workflows for these 4 major use cases with virtual facility integration, robotic simulation, industrial robot fleets, and autonomous vehicle simulation. And it's all built on top of OpenUSD as the foundational piece that brings all this data together. So virtual worlds, physical AI needs virtual worlds with which to train these robots, right? Partners like Agility are working to fill that sim-to-real gap, all right, where everything that happens in the virtual world should mirror what's happening in the real world, and the robot should perceive and as such and act accordingly, right? And you want to scale to the scene on the right, right, where you have entire robotic fleets inside of a facility, right? Interacting with humans and operating with maximum efficiency and safety. And this requires scaling your synthetic data and training scenarios in OpenUSD to run anywhere. So where do these robots learn to be robots? You need some pretty beefy AI infrastructure for that. This is where more digital twins come into play, right? On the far left, you can see NVIDIA's workflows for doing product review and lifecycle management of its PCBA boards. This is Blackwell, and we're happy to be partnering with PTC now, incorporating these kind of workflows into Creo and into Windchill accordingly. In the middle, you could see point clouds represented as poetry from Navis streaming from an Evian server. All right, and you can use this for brownfield layout and maintenance type workflows where you scan an existing facility like this data center, right, and then you can replace equipment accordingly, tweak layouts over time, and so on and so forth. And then finally, on the right, you could see a workflow for laying out a new facility like a data center here, right? Putting a CDU from Vertiv, right? And then running analytic simulations like electrical simulations from ETAP, thermal simulations from Cadence, right? And then really optimizing for token output and energy efficiency end to end to produce the kind of intelligence that is needed to train these robots. So what are the foundational capabilities that are needed for robot simulations, the basics of what they need to perceive the world and act upon it, right? On the top, they need to visualize, right? You need to be able to see the geometry and the appearance represented by its visual materials. Then you need some basic physics and kinematics that match the kinematic joints that were defined by the robot. So I could do things like these pick and place tasks, right? Bottom left, you need semantic labels for machine learning, object identification. You saw that in Mingyu's talk earlier today, right? That's very, very fundamental characteristic that's needed for perception. And then on the bottom right, you need to think about non-visual materials and non-visual sensors so that you could use technologies like sensor RTX to faithfully produce sensor simulation in the virtual world that matches what the robot will perceive through its sensors in the real world. And then when you simulate in Omniverse with these baseline scenarios, right, as you saw in Mingyu's talk as well, you can then basically upscale it in Cosmos, produce more synthetic variations of what you're doing, very, very different things, like time of day, weather conditions, things like that, train accordingly, and get improved robot policies, feed them back into Omniverse, and you get this nice virtuous cycle between Omniverse and Cosmos to really flesh out a very rich complement of data for the robot to learn from that would otherwise take many, many lifetimes to perceive. All right, so let's talk about the content journey and the standardization, how it will help fulfill the vision that I just laid out. So the content journey is about populating this virtual world, this stage in USD terms, with many contributions, right? There's lots of multidisciplinary workflows and capabilities in every scenario that all needs to come together through USD. There are a lot of existing standards out there to be mapped. So for geometry, like the obvious one is CAD for these robots and the environments in which the industrial environments in which they are operating. For materials and rendering, the community is converging towards Material X and OpenPBR as a standard there. For kinematics, we have existing data models from URDF and MJCF to be mapped in. And for machine data, we have standards like MTConnect along with its companion spec in OPCUA and so on and so forth, right? You can see Vondelbot's starting to go through this journey as they bring this robot from SolidWorks into Blender, making annotations there, bringing it into Omniverse and Nova and so forth. So we're seeing a lot of good momentum around the prototype aspects of this, but it's really time to sort of really zero in on USD as this standard of standards to unify this very diverse content ecosystem. So this is where we introduce the concept of SimReady, right? How do you segment the capabilities that are needed for the agents in these virtual worlds and the equipment in these virtual worlds accordingly, right? So that you can optimize and define perception and action tasks accordingly. So the bottom matches what I mentioned before about the really most foundational pieces that we're working on hardening into standards now. What's needed for basic ground truth and visual sensors from transforms, meshes, materials, semantic labels, right? Then getting into the non-visual sensors, the rigid bodies. The top also needs to be worked on now as well, this frontier development that is maybe not ready for standardization yet, but we're willing to start prototyping, seeing some signs of life for proving out operational workflows and the electrical and thermal, that I showed that was needed to build out the AI infrastructure that's needed to train these robots, right? But the key thing is to segment them into this stack, right, and then prioritize accordingly, but always be honest about, are you developing a standard, or are you doing frontier development that will become a standard? And what's the path for a frontier development to become a standard? Here's an example of something that we're doing that's more frontier, right? Where as we define these SimReady capabilities, you want to be able to structure your data to leverage USD's composability, right? You want to be able to separate your concerns into different USD layers, right? So that all the different standards can feed different layers. So this is a proposed asset structure that we have for robots and USD that does just that, right? Where you have your asset source, you transform it accordingly into features that represent roughly represent those capabilities: the physics, the sensors, the ROS data, the controls, and so on and so forth, right? And you could, as you move from left to right, this very much matches traditional extract, transform, load pipelines for robots in USD. And you can learn more at the QR code. So this is what it looks like in practice as a SimReady pipeline, taking a robot arm from CAD and URDF, organizing it for simulation, adding a physics layer, and so on and so forth. We've released a new version of the Exchange SDK 2.0.1. It's available here both on GitHub and PyPy that we also use to start implementing a Mujoko to USD converter, right? And you can see it in action here where you see the same robot in USD view and in Mujoko both as USD and MJCF, and you see the behaviors matching accordingly. So that's all great. There's lots of enablement happening, but what can you do as a start for yourself, right? And these are some of the things I think everyone can start with. We have DLI courses, right, which you can learn those first principles, those foundational pieces of OpenUSD. There's now a developer certification available that's built from that curriculum, right? That curriculum prepares you for it. There's a study guide. It's all the curriculum is free. The certification costs $200, but it's free here at SIGGRAPH. I'll give more details on that shortly. But yeah, that's a great way to get started. If you want to get hands-on, I highly recommend trying the CAD converter. Right, this really that's really the key step in the content journey for industrial data for robotics. Right, is getting some basic CAD into USD so you have something that visualizes. Start getting hands-on with the asset validator that we have as a framework. Right, so this is going to be your typical workflow in the content journey is producing some USD, validating it against best practices and standards, right, and then filling the gaps accordingly. Another thing that we have put out on GitHub are a library of materials for physical AI. And so you can prepare for the standards that are coming there by learning about them and using them accordingly. These are OpenPBR based, and they also include attributes for those non-visual materials and sensors that I mentioned for sensor rendering. But it's really time to get serious about standardization. There's a lot of good work going on, but if it's all happening with everyone has their own custom schema, then all we end up with is a big content zoo. So I really would we're at an inflection point now. Everything I said about USD, about what makes it great, is that it's extremely flexible, but that flexibility really comes with a double-edged sword of tons of ambiguities. And everyone's moving fast, including us at NVIDIA right now, but we really need to balance expedience with scalability. If we're super expedient and we end up with 1 million custom schemas, it's going to be an integration nightmare, right? And so standardization is everyone's job. We've mapped out a playbook for standardization that you can find out more about the QR code, and this is a super high-level overview of it, but it identifies the personas and the activities that happen from start to finish here. This is also a way to apply to the content journey, right? Starting with getting high-fidelity 3D data from source apps to USD, and then identifying what to you as for your workflows, what is the key non-3D data that needs to travel through USD, right? So for example, I mentioned earlier about the data centers being electrical and thermal being some of the key non-3D data. There's others that we're looking into as well, right? But then, so taking on that frontier development to start the process, but finishing the hardening process for the foundational elements that are needed, like geometry and visual materials, right? Again, that intellectual honesty of where you are in the frontier versus hardening phase, right? And when you're on that frontier, really tightly scope your use cases accordingly, right? And look into paradigms like as-a-pass and dynamic payloads for external data binding, right? And then, yeah, again, see where you can always check to see where you are in this flow to learn more, right? And then, but the key collateral that should flesh out any standard for content in USD is the specification itself, which has a lot of requirements for what's needed for visualizable geometry, for example, the validators that you can run against it to know when you're out of band and how to fix it, sample assets that exemplify how like compliant content, and then end-to-end workflow guides that show how those assets were made with a full reference pipeline that you can adapt for yourself. Within NVIDIA, we found this even challenging within NVIDIA. When you have a lot of smart people spread out all over the globe, it turns out you end up with lots of different variants of SimReady. So we are now centralizing our SimReady development into a foundation, right? And we've spun up 3 flywheels that feed that foundation. There's feature scaling, where you're defining feature specs. There's pipeline scaling, where you're implementing pipelines to create content that can support those features, and then a standardization review in which you're iteratively hardening those features, from frontier to feature to standards accordingly. What does it look like in practice? At the feature phase, you write your spec, right, and you write your validator, and maybe you're manually making some toy content to prove it out that the runtime can support it and can be augmented to support it, right? You don't necessarily have a pipeline yet. You're just proving out the data model and the runtime. From there, if you're happy with it, right, or you really need to sort of need that feature to flesh out other pieces of the workflow, right, and you need to start building up a library of content that supports that feature, right, then you implement the pipeline around it, and you write pipeline guides for how to execute that pipeline and what are the component parts and so on and so forth, right. As you go through standardization review, right, you're gonna argue over the severity of rules, the priority of rules, the factoring of rules, all that kind of stuff, right? And you're going to come out with an agreement and basically a revised specification, right, which then needs to go back through the feature development to revise the spec accordingly, and the pipeline scaling to then revise the pipeline and the content accordingly, so that everything is in line with the agreed upon standard. So we've hit a lot of challenges with standardization, and here's some things that I've found that mitigate them. The key thing is to know when to go pencils down and iterate. Everything that's happening in digital twins, and especially within USD, is a rapidly evolving technology. So we've been trying to standardize a moving target. We found that out with the core spec, which I'll go into in a little bit, but new features were coming even into the USD core as we were writing the core spec. So it was a constant exercise for us to decide, okay, is that new feature in scope or not? All right, some of the new features that came in were the relocates composition arc, animation splines. There were things in scope like scene graph instancing and path expressions that we ended up taking out of scope just because we really needed to go pencils down and share what we had. I'll go into that into more detail. But the key is that we're taking an incremental approach. This applies to frontier development as well. We're seeing a lot of great work around Gaussians, not just in USD, but in GLTF and SPZ, right? So it's great to see that conversation going, and I think, right, there's approaches there where we can all align on a minimal baseline data model. We really don't want to constrain innovation around Gaussians, but we want to sort of find the minimal cut of things that are stable now. USD has a great mechanism called API schemas, in which you can then basically add more properties on top of a baseline schema. All right, this is where you can continue feature development on Gaussians even while standardizing the most common aspects of it across stakeholders. All right, and over time, widely adopted features could then get folded into baseline schema accordingly. You think of them like the way vendor extensions get promoted to standards in other things like OpenGL. As I said before, OpenUSD is powerfully flexible, but it needs standards to eliminate ambiguity. Some examples here are like different domains may have different feature requirements or priorities or even conventions. USD allows you to declare your data in any up axis or units that you want. The robotics ecosystem is largely in meters, so that might be something that we're proposing to standardize for USD that's used for those domains. And how do you declare that accordingly? There's a proposal now around profiles and capabilities from USD, which provides a mechanism for segmenting these domain standards accordingly. And finally, what I mean when I go pencils down is you really want to specify what works today, right? And you can do that, maybe it doesn't even have to be a formal spec, right? Some Kickstarter enablement of like, here's a literal workflow guide of how to run CAD converter so that you know that it's your output USD is visualizable in USD View and in any other USD compliant renderer, right? But at the same time, be honest, right? That you are standardizing against a moving target. So again, you need to assure everyone that you're going to maintain content compatibility and provide upgrade and migration paths as those paradigms evolve. So let's talk a little bit about what the process of Core Spec 1.0, which we now have a draft deliverable that's been approved by the working group. So thanks to all our authors and contributors, particularly from Pixar, and of course, NVIDIA, Apple, Autodesk, and Chaos Group were the lead contributors to this output. And you can see here a little snippets of what we specified here. There is a novel data type in USD called listops, which is a way of constructing a list of elements, right? Which is very useful. This is how you can specify the API schemas that live on your prims. You can also specify the list of references that contribute to the objects in your scene, and so on and so forth. So it's a really fundamental type, but it's unique to USD, right? So you can see we made a railroad diagram to specify its grammar, right? We go into the specifics of its data type. We define how it feeds into the document data model for the field-like references, right? And then we talk about how references play a role in composition, and finally how that all feeds into the value resolution algorithm. So we have this nice sort of end-to-end thing. And you imagine if we didn't go pencils down, right? None of this super useful information would ever be available to anyone. So that's why it's really important to really know when you want to ship a 1.0 and be declarative about what you want to put in a 1.1 and so on. Again, like there's, like I said, every spec needs to have the collateral that's needed to comply with it. So we've also been implementing sample implementations and compliance testing. We've released a beta release of our listops implementations and the USDA and USDC parsers. So again, here you can see the test for the listop implementation and the test for parsing human readable listops from USDA and the test for parsing listops from the binary crate encoding of USDC. NVIDIA has been all in on USD since at least 2020 when we added the Python 3 bindings, right? Today we're happy to launch the Pro certification and the Majoko interop, right? And our key goals for the rest of the year, right, is like getting Core Spec 1.0 approved, really proving out this SIM-ready foundation approach to centralizing SIM-ready development and onboarding some lighthouse partners with that so we could start seeding the standardization efforts around that. You saw some of the point cloud streaming that I showed earlier. Again, the exciting work around Gaussians and starting to formalize these data binding paradigms that have recurred throughout my talk. So the call to action, right? So really grab these QR codes. First, learn and get certified. Second, get kickstarted on your content journey with CAD Converter. Start onboarding with compliance workflows with Asset Validator. But maybe most importantly, share your domain expertise. The last one is a link to the AOUSD forums, but I think there's lots of other ways to engage. AOUSD has liaison relationships with Kronos, which also includes the Metaverse Standards forums, as well as Academy Software Foundation, which has Slack channels, USD work groups, and so forth. But we really need to bridge these knowledge gaps just as we did between 3D and AI. A lot of us know USD, but we don't know data center engineering, and we don't know robotics, and so on and so forth, right? And for all the domains that digital twins span, we're all going to need to share our knowledge together in order to fulfill the vision. There's many other AOUSD activities going on at SIGGRAPH. You can see the full schedule at this QR code. We have our developer meetup tonight, so I hope to see you there. So we can get more conversations going. I can learn more about what you're trying to do, and I could tell you more about what we're trying to achieve and what the priorities and timelines are that inform that. Finally, I'd like to pay tribute to our good friend and colleague, Phil Sawicki. Sorry, it's still a little bit raw because it's been less than 2 months since he passed. Super sudden. I was his manager and been working with him for a few years, but he's really a true champion in every sense of the word. He's really a huge contributor to USD, leader in the community through things like the web working group, and really a big contributor to everything that I talked about today. His fingerprints are all over this talk, and yeah, I suspected something like this would happen. So thank you for being here with me, and I know a lot of you knew him as well. So thank you. one of the last things that Phil worked on was the certification, and it was, even on Teams calls, you could see like other folks really light up when you spoke, not just NVIDIAns, but there were a lot of other companies that contributed to the certification process, and so we're happy to offer that exam for free here at this conference, and I think I'm already seeing it making a huge difference. I never thought I would see so many people get certified from many different industries, and I can't wait to see where it goes. I think that's my time. There's about 10 minutes or so for questions. Yeah.
Thank you, Aaron. So we do have 10 minutes for questions, so please raise your hand, and we will have a mic, and someone will come to you.
Thanks for the talk, Aaron. I'm curious if there's been like much of a push, I guess, within OpenUSD to standardize on like a collaborative live link sort of experience kind of thing.
Not that specifically. Like, what aspect of live do you mean? So USD itself, you can always push your changes to your USD and save it, and it'll get picked up accordingly. The change management with USD is not necessarily optimized for that kind of thing, but there are technologies in Omniverse like live layers, right, which effectively are not officially part of composition, right, but are more used for like transmitting live game engine style type updates and things like that. But yeah, what kind of workflows are you looking to?
Yeah, that's kind of what I have in mind is, I guess, what Omniverse does with LiveLink. I guess Pixar and those sort of companies generally use something like a source control, like Perforce or something like that, to back their data, to host their USD files and merge them and all that kind of stuff. But yeah, I guess like I see a lot of value in that sort of moving that everything left or whatever, and yeah, having a live collaboration, almost like a Google Docs sort of workflow.
Gotcha. Yeah, I think live layers is part of that puzzle, but it's not really meant for it's meant for like that game engine engine style type updates where I don't think it's suited for making structural updates and pushing them out and that kind of thing. Yeah, I would say it's not really. That wouldn't necessarily be an AOUSD activity. I think that would maybe be because it's not really a standard per se, but it's more about what are the performance characteristics of the OpenUSD implementation that you would like to zero in on that makes that better. All right. I think Pixar has been making a lot of improvements to change management accordingly and things like that. But it'll be like. I think what you could use the AOSD for there is more identifying which areas of change management you would want to are most important to you, right? And then maybe we can make a list accordingly and agree upon which priorities to address them in. Again, incremental approach, right? Yeah.
Okay, awesome.
Yeah.
Thanks, Aaron.
Yeah.
All right, we have a few questions in the front right there.
Hi, I was curious if there's been any work on Gaussian splat integration and something like text-to-world with Gaussian splats inside Omniverse?
Yeah, I think there's going to be a talk about that later today. But yeah, we have the new rec technology and Gaussians for scene reconstruction, that kind of stuff. But again, it's really important there to align with other folks who are also doing Gaussians in USD and make sure that we don't end up with a bunch of content that only works in Omniverse or in Apple devices and so on and so forth.
All right, we have time for one more question. Maybe we can have one in the front here. I got it. Here you go.
Well, thank you very much. Interesting presentation. Regarding the integration of real-world data, I see that so far you're covering a lot of the mechanical CAD data. At some point in time, you need to enclose this in a building. So what is the current state of discussion about introducing IFC or interoperating with IFC for architectural and construction data?
Sure. So the AOUSD has a liaison relationship with Building Smart, and there is a AECO interest group in AOUSD in which Building Smart representatives are meeting with AOUSD representatives to align accordingly. But I know in talking with Building Smart folks, they studied USD quite extensively as they formulated IFC 5. So that's where those conversations are happening right now.
ETA on seeing anything that might be usable?
I don't have a specific time frame per se. Yeah.
Awesome. So that's all the time that we have. So thank you so much, Aaron Luke, for that presentation.